Welcome back to the Foundry by Forge College. So, in our previous lesson, Foundations of Network Efficiency and Gulfstream, we covered all the underlying theory of how transactions are proactively forwarded. But theory, as literally any sleep-deprived engineer will tell you, well, it only gets you so far. Today, we're diving into designing network efficiency benchmarks for Gulfstream. Grab your hard hats and clipboards, folks, because we're stepping right into the role of chief engineer to build a rock-solid, practical blueprint that proves exactly how Gulfstream impacts network efficiency in the real world.
Now this brings us face to face with the ultimate engineering dilemma. How on earth do we measure the unmeasurable? I mean, it's great to know the theoretical why, right? But real engineering requires hard numbers. If Gulfstream is fundamentally changing where and when transactions sit in the network, we absolutely need a mathematically sound blueprint to capture those fleeting data flows in real time.
Okay, here's our technical schematic for this explainer. We're going to cover 1. The benchmark blueprint. 2. 3 vital network metrics. 3. Designing the data schema. 4. Executing a concrete benchmark. 5. Building the measurement script. And finally, 6. Review and next steps. Don't worry if you're new to some of this. We are moving deliberately from abstract theory straight into getting our hands dirty with practical application.
All right, jumping right into Section 1, the benchmark blueprint.
Okay, let's dive into this. In any engineering project, jumping straight to the keyboard without a plan is basically a recipe for an explosive disaster. Building a solid design plan first seriously reduces ambiguity later on when you're interpreting the results. So the absolute golden rule here? Define precise observables before you write a single line of code. Our specific hypothesis is pretty simple. We want to test if proactive forwarding actually changes transaction residency and speed. But to prove that, we have to know exactly what network signals we're hunting for.
Moving right along to Section 2, 3 vital network metrics.
So to really measure Gulfstream's impact, we need to chop the transaction lifecycle up into specific, measurable components. Think of the network like a massive global package delivery service. If we want to know why a package arrived incredibly fast or why it got mysteriously delayed, we have to track it at specific checkpoints. Our first metric is propagation delay. This is simply the time between the client submitting the transaction and it being first seen at a validator. It's exactly like dropping off an express package at the local post office and stamping the exact millisecond it hits the front counter.
Next up is leader queue residency. This one measures the time between that first seen event and the transaction's actual arrival at the target slot leader. Continuing that delivery analogy, this phase is essentially the validator to leader handoff. It's the time it takes to move your package from the local post office and load it onto the specific delivery truck that's heading to its final destination. And finally, we have confirmation latency. This is the time between the leader accepting the transaction and the final confirmation. Think of this as the final delivery signature, capturing the exact moment the RPC confirms finality and your package is officially in the recipient's hands. Measuring all 3 of these gives us the complete end-to-end picture we need.
Let's hit Section 3, designing the data schema.
We know what we're measuring, but now we need a meticulously organized place to put those measurements. If we don't have strict engineering specs and data schemas before writing actual code, we'll just end up comparing apples to blurry, misshapen oranges. So here is our master data schema. We need precise columns for our sample ID, emit timestamps, validator timestamps, leader receipt, and confirmation. I constantly joke with my peers that absolutely nothing causes more existential dread than a missing or mangled timestamp in a dataset. So here's our critical rule. Strictly use UTS ISO 8601 formatting. Absolutely no localized, unreliable human timestamps. We need cold, hard machine time to calculate our delays properly.
Onward to Section 4, executing a concrete benchmark.
So with our blueprint and schema totally locked in, how do we actually run this experiment in a real test cluster without, accidentally crashing the whole thing? We do it by setting up a strict A/B test. We compare a 10-minute baseline phase where Gulfstream is temporarily disabled against the 10-minute treatment phase with it turned on. Our goal here is to collect exactly 1,000 samples per phase, which keeps the submission rate low enough that we don't saturate the cluster and totally skew our own numbers.
And here is the step-by-step procedure. First, select your vantage points. Second, fix the emission pattern to 10 transactions per second. Third, measure and collect the data. And fourth, aggressively control for noise by running these back-to-back. By the way, if setting up local test clusters sounds a little intimidating, Forge College's broader courses and learning programs are just phenomenal resources for mastering these exact test environments. Definitely worth checking out.
Let's jump into Section 5, Building the Measurement Script.
This is the prototype phase where the rubber finally meets the road, translating our technical blueprint into an actual minimal measurement script. Here's the pseudocode flow. We generate a sample ID, record the emit timestamp, submit the transaction via RPC, and then poll our observer for first seen. We query for leader receipt, wait for confirmation, and finally write out a JSON line. A massive piece of advice here. Handle your nulls explicitly. If an observer times out, log it as a null, don't just drop the data point. Also, make sure to write your outputs atomically with periodic fsyncs so you literally don't lose all your precious data if a node happens to crash midway through your test.
And that brings us to Section 6, Review and Next Steps. We've built the script, we know the schema, and we're officially at the sign-off phase of our engineering blueprint. Let's look at the expected results. Now, what's really interesting about this slide is what a hypothetical victory actually looks like. If you run this script and see numbers like these, you can absolutely pop the champagne, proving that Gulfstream dropped the average leader queue residency from, say, 25 milliseconds down to 10. We've nailed it. We've captured the unmeasurable and mathematically quantified exactly how proactive forwarding speeds up the network.
So, the ultimate question is, are you ready to ship your script and collect the transaction flows? You now have the full engineering blueprint to run these experiments yourself. This sets us up perfectly for our next steps in this advanced Solana concepts track, where we'll actually start analyzing these data sets. To dive deeper into this subject and to explore other amazing Web3 topics, be sure to visit forge.college. Keep building, keep measuring, and I'll see you in the next explainer.